Next step, we're going to simplify. We're going to make it much, much simpler than this general equation, this function f of all of these different parameters or variables. All right, and so instead I'm going to linearize it. And that means I'm going to take each variable, like I, and I'm just going to multiply it by some parameter value. Numbers are made up. And I'm going to keep the sign that I need. So here I've got a positive sign with income, and that's going to mean that this product is a normal good. If income goes up, I'm going to take that income increase and multiply it by 1/10, and that's going to raise the demand, the quantity demanded for the product. All right, so I'm assuming because of the plus here that it's a normal good. Price of a substitute multiplied by 1/2, some parameter value, also plus, which means, well, it's a substitute good. Price of some other good that has a positive relationship will be called a substitute. PC is the price of a complement. I've got some other variable or parameter value here, 1/4, again, a made up number, just so that I could kind of put a relationship together, positive and negative as appropriate, and its effect on demand, and be able to write it down a little bit more explicitly. Now, notice this last bullet down here. I say let the 5, this fixed term at the end, let's let that number incorporate all of the other variables that I specified before. So that's going to be tastes, future price, future income, and the number of buyers is all somehow incorporated into this fixed term 5. It's a small number, maybe it should be bigger, but again, I'm just trying to keep it simple so that we can work with it. Okay, these are examples of simplifying assumptions so that we can actually work with this relationship. Okay, now, when we derive the demand function for coffee, we're going to basically be asking for the relationship right here. What is the relationship between the demand for the product and the price of the product itself? But we're aware of the fact that there's all of these other variables that also affect the value of demand. Okay, there's income, there's price of substitutes, complements, and so forth. And these things, we're going to need to have a value for them in order to figure out this relationship between demand and the price. All right, so that's where the ceteris paribus assumption kind of comes in. We're going to fix a value for everything else, and we're going to plug it in to simplify the relationship. So let's make up some numbers. Let's let I equal 300. Okay, and if it's 300, then we plug that in, and demand is going to be affected by 300 divided by 10, or it's going to be added up by 30, for example. Okay, we're going to imagine that the price of a substitute good is $20. The price of a complement is $20, like cream. And again, 5 incorporates everything else. So let's plug in some fixed values for that and see what happens. Okay, here we go. Here's the demand function linearized. Here it is with all of the values that I just specified plugged in. Next step is simplifying it. So I've got minus P plus 30 plus 10 minus 5 plus 5. That's all going to simplify to this particular relationship. D is equal to 40 minus P. Now, this 40, inside, we've got income and price of substitutes and price of complements and NB and future price and future income. All of these variables are affecting this value 40. But they're in there, and I'm not going to worry about them now. Now I've just got it all in there, and I've got a relationship between the quantity demanded Q and the price that prevails in the marketplace, and I can now plot and create a market demand function. Let's do that. Here we go. The relationship here, I'll write it this way. QD is equal to 40 minus the price of coffee from before. Okay, well, how do we plot that? Well, we can create a schedule. Here's a demand schedule. And we plug in various values. Let's plug in a price of 40. What would we get? 40 minus 40 is 0. Let's plug in a price of 30. What would we get? 40 minus 30 is 10. Plug in a price of 20. So we can do this. All of the different prices we might plug in, we get different demands. Now you'll notice I make this a little bit more complicated now. I'm drawing this from some other textbook. This is in millions of pounds per month. So always pay attention to the units on the graph. Okay, other thing I want to emphasize. So here's our plot right here. If the price is 40, quantity demanded is 0. So that's 0 measured on this axis. If the price is 30, plug it in here, then the quantity demanded is 10. That's going to give me this value right here on the graph, 30 and 10. If the price is 20, like here, that's going to give me a value of 20. So I take 20 on the price axis, carry it over to the quantity axis, and I get this point right there. So these points, these things match the individual points here, right? And so forth. Now, there's one other thing I want to really emphasize here, because this is going to start to get trickier as we move forward. Get rid of some of this mess. And that is, note that we've got the quantity of a product, coffee in this particular example, on the horizontal axis, but we've got price that's measured on the vertical axis, right? So this is price in dollars per pound. So we're plotting the price of the product itself, the own price, against the quantity demanded for the product, and that's what's on the axes now. Notice that's different from the graphs we've done before. In the previous graphs up here, we didn't have price and quantity. We had apples on one axis and oranges on the other axis. So this is a display showing us something different than this is showing us. And we've got to keep track of what it is we're plotting on the diagram itself and how we're measuring those individual items, because the measurements are telling us what that relationship is presenting. This is where this class is different than math. In math, we would just put the axis X and we would put the axis Y, and we wouldn't care about how we're measuring those individual things. We're just measuring the interrelationship between some variable X and some variable Y. Well, now it's not as random as that. Now it's specifically a particular product like coffee being demanded, and that's what we're plotting on the horizontal axis. And it's specifically the price of coffee that we're plotting on the vertical axis. And this function then is the demand function. It's telling you how much would be demanded in the marketplace in millions of pounds for each and every price that might conceivably be prevailing in the marketplace. Okay? Negative relationship means that this is a negatively sloped line, and that's what we would expect demand for a product to exhibit. All right, now the last thing we want to do here, do a shift of the demand function. We're going to think about how changes in the variables itself that are incorporated into that 40. You know, we've got 40 minus P, and in this 40, there's a whole bunch of stuff. Well, we're now going to think about how and in which direction this graph is going to kind of change or shift around in response to changes in the invisible variables now. So in this function, there are some invisible variables. These are the ones that were specified previously. What we want to do is we want to go through and change one of those invisible variables and kind of see how that changes our representation of the demand curve on the diagram here. All right, so let's go ahead and do that. So let's go back to the specification we had before here, and let's imagine that income is changing from 300 to 200 units. So income I, we might say, goes down. All right, well, now we want to figure out, well, how is that going to affect the relationship between the price and the quantity demanded for the individual good? Okay, and here, some terminology becomes a little bit complicated. We've got two different terms we'll often use, demand and then demand function, or demand curve is another way of saying the same thing as function. All right, now demand itself is plotted along this axis. So this is the quantity demanded. And if we say, well, what happens to the quantity demanded when, say, there's an increase in the price of the good? We can represent that right here on the diagram. If the price of coffee goes up from 20 to 30, well, then the quantity demanded falls from 20 to 10, right? So if the price goes up from 20 to 30, the quantity demanded falls from 20 to 10. But the demand function doesn't change. It still stays there in exactly the same position. When you change the price, the quantity demanded changes, but the demand curve or the demand function does not change. But that's different when we change a variable that's not graphed on the diagram. Okay, so now we're going to change I, and I, you will notice, no I. There's no I up here. There's no I over here. Okay, there's no I plotted on the axis. But I is affecting this 40 we know from before. So how is it going to work? Come back out here and plug in the new value of 200 into the expression. Keep the other variables the same. Okay, so ceteris paribus is being incorporated. Change the income, but not anything else. And that's going to change the demand function to this. Now it's going to be D is equal to 30 minus P rather than 40 minus P. And that's all because income dropped from 300 to 200. Okay, well, let's see what happens. Here's the new demand schedule. So this is the demand schedule. Q is demanded is equal to 40 minus P. So this is the quantity demanded at 40 minus P, which is when I is equal to 300. And this is the quantity demanded when I is equal to 200. And we get 30 minus P instead. All right, well, let's plot this schedule. If the price is 40 and you've got QD is equal to 30 minus P, we'd actually end up with a value equal to minus 10. But minus 10 doesn't make any sense. How could you demand a negative quantity of an individual good? So we will generally bound these variables and say QD has to be greater than or equal to 0. It doesn't make sense for it to be less than 0. And that's kind of an implicit assumption that I've made here with this particular function. All right, so we're going to leave it. It just doesn't exist. But when the price falls to 30, then we've got a clear demand of 0. When the price falls to 20, we've got a demand of 10 from this equation up here. Okay, and so when we plot it out, we're going to get this green line on the diagram. And that green line represents the relationship now between the price of coffee and the quantity demanded of coffee at the new income level, I equals 200. So when I goes up, it causes demand, the demand curve shifts left. Just like we're seeing on the diagram. So we increase a variable that's not represented in the diagram, it's not on the axes, and that's going to actually cause a change in the demand relationship. Now notice what we have happening here. Let's say we fix the price for the product at 20, just hypothetically. At the original income level of 300, the quantity demanded would have been 20 units. So when I shifts down, demand curve shifts left. At the same fixed price of 20, demand is going to go down from 10 to 20 entirely because of the income drop. And that's also, we note, specifying or indicating that the income or the good is a normal good in this particular case. Decrease in income caused a decrease in demand of the product from 20 to 10. But it also shifts the entire demand curve. So the demand curve's position is affected by a change in the other variables that are affecting the intercept term, the 40 here. And income is just one of those. Other ones include the price of substitutes, the price of complements, and all the other things.